On the last video, we went from the equation to drawing the graph. In this video, we're going to be going from the graph to writing the equation. So taking a look at the graph, it's hard to tell whether this is a sine or a cosine curve. But one thing we do know it has in common is that there is a maximum line, there is a minimum line, and halfway in between those two, there's a sinusoidal axis. So when I counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, my maximum line was at 12. My minimum line was at -6. Halfway in between 12 and -6, that's an 18, that's a 18 unit distance. Halfway in between is when y equals 1, 2, 3. Because 9 from 12 is 3, and 9 from 3 is -6. So there's my sinusoidal axis, my maximum, and my midline. I can also take my graph and I can highlight what I know is critical points. Everywhere that the graph crosses the midline is a critical point. Everywhere the graph has a maximum or a minimum is a critical point. So I can mark critical points all over this graph. That's going to help me with a couple of things. First of all, it's going to help me see that none of them cross on the y-axis, so there is a phase shift. And it's also going to help me identify if I'm wanting to look at this equation as whether a sine curve or a cosine curve. So let's fill in what we can find first. Where is the sinusoidal axis? The sinusoidal axis is the midline, which is at 3. The amplitude is the distance from the midline to the maximum, so that's a difference of 9. Our phase shift is going to depend on whether we use sine or cosine, so we're going to skip that for just a second. The period, let's pick a critical point. Let's pick this critical point right here, and let's go until it starts to repeat itself. So that we're going to go until the graph starts to repeat itself, and it stops right here. That's -3, 1, 2, 3, and this is +7. Well, how far apart is it from -3 to +7? So let's count. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The period length is 10. We also know that we could find the period by doing 360 divided by b. Well, if we know the period, we can set that equal to 360 divided by b and solve for our new value. 360 divided by 36, if b was 36, if my period constant was 36, that would give me a period length of 10. Also, my quarter period is 2.5. So I know that each of these critical values are 2.5 apart. So -3, -0.5, +2, 4.5, +7. So I have a lot of information and I haven't even written an equation yet. The next thing we look at is they told us to write the equation using sine. Sine starts at the midline, so we're going to use one of these critical points. There's 4 places we could start it. I would always prefer, if possible, to draw a positive sign. So I'm not going to start it where the first thing it does is drop, not where the first thing is drop. So I'm going to start it at one of these two. The second thing I like to know is I'd like to be able to see a full cycle. And the only one that we can see a full cycle is this one right here. I can see where the graph starts, where one cycle starts, and where one cycle ends. So where is that shift? How far did that shift move? It moved left 3. That's a distance of 1, 2, 3. So our phase shift is -3. Now using this, if we write the sine equation, I would write y equals, remember last time we did a, which is the amplitude, 9, times sine of b, which is the not the period, but the period constant, 36, times x minus c. Well, c is -3, so it's minus -3, so it's +3. And then finally, plus the sinusoidal axis. There is the equation of this graph written as a sine function with this as our phase shift. Now, talk about critical points. We said this point was negative 3, 0. I mean, negative 3, 3. This point is negative 1/2, 12. So that phase shift, it says what would change if I wanted to write this as a cosine equation. Well, notice if I started here and I drew until it started repeating itself, how far apart are those 2 points? Well, this is negative 1/2. This is 9.5. That's still a period of 10. That is still a period of 10. So that didn't change. The amplitude certainly didn't change because I didn't redraw the graph. The period length didn't change, so my B value isn't going to change. The only thing that changes is the phase shift. The phase shift changes when the graph is changed to a different function. And my phase shift would then, in this equation, be negative 1/2. And that's if we're using cosine, because cosine starts at the top. We would draw the graph right here, still following, and end right there. So there's my cosine curve. Notice it's still the same equation. It's just the cycle we look at is a little different. So the equation would be y equals 9 cosine of 36 times x minus negative 1/2. Minus negative 1/2 is plus 1/2 plus 3. So the equation is almost identical. The only thing that has changed is the fact that my phase shift is different because sine starts at a midline and cosine starts at a maximum or minimum. Let's look at the second example of this. When we look at the graph, a couple things we need to notice. First of all, these numbers go from negative 50 to 50. It is not a good idea anytime this happens to use radians. So let's make sure that we're using degrees with our problem. And the question is, would it be easier to use sine or cosine? I don't know yet. The only way I'm going to be able to tell is I'm going to draw my maximum, which is actually at negative 1. I'm going to draw my minimum, which is at negative 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 9. How far apart are those two numbers? They're 8 apart. So my amplitude is half of that. My amplitude is going to be 4, but my sinusoidal axis, 1, 2, 3, 4, right here, my sinusoidal axis, where does that exist? At negative 5. Start at the x-axis, 1, 2, 3, 4, 5. That's actually at negative 5. So I have my sinusoidal axis. Let's mark our key points. Here, 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 and here. Take a look at this graph. None of these are what we call pretty points. In other words, they don't cross at perfectly even spaces except for this one and this one. So I'm going to suggest that you use either this point or this point so that we get a positive. Even the negative sine value is in a kind of a gross spot because we don't know exactly where that is. But this one right here, this point right here exists at 10, 20, 30, 40, 50, 60, negative 60, negative 5. And this point right here occurs at 30, negative 5. Because we know those 2 points, I know how far apart they are. I know the phase shift, which is left 60. I know the period length, which is 90. I can find the B value. 360 divided by 90 is 4. So what's my equation? Y equals 4 times the sine, because that's a sine curve. This graph that we chose is a sine curve of 4 times x plus 60 minus 5.